Hello and welcome to this video. In this video, we are looking at Python generators. If you have ever tried to process a massive file or a huge dataset in Python, you have probably crashed your program with an out-of-memory error. Today, I'm going to show you how to fix that using one of the most powerful keywords in Python, the yield keyword. Let's start by looking at how most beginners write Python code. Here I have a standard function called getSquares that takes in an integer as an input parameter, and it creates a list of all the squares from 1 to n. Inside the function, we create an empty list, run a simple for loop to compute the squares and append the results one by one to the list, and finally return the result. Down in the main block, we are going to run this function with n set to 10 million. We start a timer, call our function and run a sum on the results. And then we stop the timer and prints out the total execution time and the memory size, the memory consumed by the result object. Let's run it. As you can see, the result is computed and the execution time is around 0.67 seconds, and our result object consumed 84.97 megabytes of RAM. Now this 85 MB does not seem like a big deal for modern computers, but imagine this. What if you are processing 10 billion numbers, or you are processing a 50 GB server log? Our computer would have to store every single piece of that data in the RAM all at once, and your system could freeze, crash, and throw an out of memory error. To solve this, we are going to turn this standard function into a generator function, and we do that using the yield keyword. I've introduced a function getSquaresYield that takes in a number as an input parameter. Notice that there is no list being created here and there is no return statement. The moment Python sees a yield keyword, it completely changes how this function operates. Instead of computing all 10 million numbers at once, the function calculates one number, hands it back to us, and then pauses. So it will not compute the squares of all 10 million numbers in one go. It will compute the square of one number, passes it to the caller, which is the main function, and pauses. Only when the main function asks for the next result, it will compute and pass the next result. Let us test this in the main block. Here we start our timer, call the function with n set to 10 million. And because generators use something called lazy evaluation, Python actually hasn't done any math yet. It just created the recipe for our numbers. To actually force the generator to do the work, we wrap it around the sum function. This asks the generator to hand us the numbers one by one so that we can add them up. And that is the biggest difference between a generator and a standard function. Generators do lazy evaluation. It doesn't compute everything beforehand. It computes and processes only when the caller asks for the value. Let us run this and compare the two. There we go. We have the result printed and the execution time is 0.63 seconds, slightly faster than the previous execution time, that is 0.67 seconds. But the biggest advantage here comes in terms of the memory consumed. We went from around 85 MB of RAM to 216 bytes. That is a massive reduction in the memory footprint. Instead of storing 10 million numbers at once, the generator only ever stored one single number in memory at a time. It computed it, handed it to the sum function, and threw it away. Then it grabbed the next one. And look at the execution time. It took around 0.63 seconds, slightly faster than the standard list because we didn't force the CPU to scramble around allocating 85 MB of RAM, and our code ran efficiently. So when should you actually use this in real world? Use generators anytime you're dealing with massive or infinite data streams. If you're parsing 20 GB server logs, yield one at a time. If you're processing 50 million rows from a database, yield them in chunks. Or if you're reading a continuous stream from an IoT sensor, use a generator to process it endlessly without ever crashing your RAM. So we've seen that generators are key to write scalable professional Python code. If this video helped you understand the yield keyword, hit the like button and subscribe for more straightforward Python tutorials. Thanks for watching, and I'll see you in the next one.